Now, this is part 1, general relativity, definition and property related to the Cartesian coordinates, classical mechanics, and electromagnetism. Now, let's go to the lecture 3, properties of Kronecker Delta and permutation symbol. The property of Kronecker Delta, okay? First of all, symmetry. Recall that delta ij is equal 1 for I is equal j, and 0 for I different from j. Okay, attention here. This is called sometimes identity operator. Why identity? From linear algebra, the identity is equal in R3, okay? It's 1, 1, 1, 0, 0, 0, 0, 0, and 0, okay? This is a diagonal, okay? The diagonal is 1. That we call identity in linear algebra. So, you see, delta 1, delta 1, 2, delta 1, 3, delta 2, 1, delta 2, 2, delta 2, 3, delta 3, 1, 3, 2, and 3, 3. You see, this obeys on this relation here. Symmetry. Now, contraction. You see, this term you hear many times about general relativity. We call contraction. You see, delta II is 3. Why delta II is 3? Okay? From the definition, delta II, it has only dummy index. Here you have 2 free index. This is dummy. So delta II is equal delta 1, 1 plus delta 2, 2 plus delta 3, 3. This is 1, this is 1, this is 1. This is a diagonal of the identity matrix. So this is equal to 3. Okay? In 3D, okay, later you see that in 4D is a little bit different. Okay? You'll see later of this. Now, let's go to this one. Identity property. Exactly what we did. Why? Delta ij, we derived this in lesson 1, I think. Delta ij, okay, here, the third one. Delta ij, we did this. You see, I is what? Is dummy. J is free. So I can write delta II. Attention now. On purpose, I'll put delta kj. AK. You see, I is dummy. If I put k, it does not interfere. Okay? So I, k, this case here, ij is the same. Okay? If you develop this, okay, for j, free index, I have delta 1j a1 plus delta 2j a2 plus delta 3j a3. You see, for j is equal 1, this will be 1, this will be 0 and 0. For j is equal to, this will be 0, this will be 1, this will be 0. J is equal 3. This will be 0, delta 3, 3 will be 1. So you can see that I can write here A, J. See? Quite simple. That we call identity property. Why identity? Because this behaves like the identity matrix. Just repeating, okay? This 1, 0, 0. This 1, 0. 0, 0, 1. Okay? This identity. Identity matrix. From linear algebra. Quite simple, okay? Linear algebra. Now, let's go to properties of Levi-Vita, okay? First of all, is skew symmetric. Attention here, skew symmetric is swapping two indices sequentially. You see, this is J on the second position. I just move to the first position, okay? You see, one important relation is this. Epsilon I j k is identical to epsilon k I j. Okay? Let's check this. When I swap in the middle, it will be minus. If I swap again, it will be plus. So this here, okay, will come on the first position. So this is plus, okay? Because I swap it twice. Very, very clear. So this antisymmetric, okay? The two ends sequentially, swapping sequentially. That's what I said. Now, contraction with the Kronecker delta. You see, delta IM. Look how interesting it is. Okay, I will erase. I'll derive here. Okay, look. Epsilon I j m delta I m. Look how interesting. I'm sorry, this ijk. I just copy from here to here. You see, just take a look. I is dummy. J, K, M, they are free. It's clear. I could, for instance, choose I as P. Epsilon P, J, K, delta P, M. Because I can exchange I, dummy, for P, Q, R, doesn't matter. Because, as I said, I'm insisting, okay, on this concept. Because I is dummy. Now, look at that. I will sum here, okay? I think I will erase here to give more space. Look at that. I'll derive here. You see how it's easy if you applied the concept sequentially. Lecture 1, lecture 2. Now, let's develop this here. So, epsilon I j k delta I m. Sum. This is equal epsilon 1 j k delta 1 m plus, attention now, I is dummy, epsilon 2 jk, delta 2 m plus epsilon 3 jk delta 3m. You see? I dummy jkm free. See, that's important. I'll put here jkm free. Now, look, let's use the definition. You see, I know that epsilon 1, 2, 3 is 1. Epsilon 1, 1, 2 is 0. Epsilon 2, 2, 3 is 0 because I have repeated index. So let's look at this. Epsilon 1. What are the possibility? J must be 2 or 3 or 3. This is K. Or, look, or epsilon, you see, 1. Now J will be 3. K must be 2. You see? How is this? Easy to see it. Okay? So, epsilon 1 jk delta 1m. Attention now. Attention now. This here, m must be 1. Why? Because m is different from 1